Exactly. Are you ready? Okay, right. Okay, good afternoon, everyone. I believe most of people already sit. Okay, welcome to the IPv6 deployment section. The purpose of this session is try to allow the operators to share their experience and especially how to using the most effective way to promote IPv6 with the affordable cost, minimal cost to have massive deployment. And so we are happy to invite all the experts here to share their experience, how they deploy the IPv6. Okay, starting from the first one, our first speaker is Jeff Houston, APNIC Chief Scientist. He is going to introduce IPv6 deployment 30 years later. So let's welcome Jeff Houston. Thank you.
I'll do this from the podium. Can someone please close those doors there? Thank you very much. Thank you. I said a few things about IPv6 in the previous session if you were here. Forget it. Forget that I said anything like that. Humans are wonderful that we can hold two opposing views in our brain at the same time. So it's a new session, a new outlook. I'm going to talk about V6 deployment, and I was asked to sort of look at the last 30 years because, believe it or not, around 30 years ago, around December 1995, the first specification, RFC 1883, was actually published. So this was the final stages, exactly 30 years ago, of going through quite an exhaustive process in the IETF of the beauty parade of protocols. And this first specification was an interesting one because after all of the heartache and a lot of tension, should we go the route of OSI and actually just give up on IP and go to the ITU-T sort of defined OSI protocols? Should we do something radically different and go to MAPS-based routing protocols? Or should we just recompile V4 with, instead of having 32 as a constant, replace it with 128 and just see what happens? Oddly enough, that's what Steve Deering and Bob Hinton proposed. And by and large, with just a couple of differences, that's what emerged from that beauty parade of protocols, a really conservative shift of just changing the size of the address field. So this is a picture of 20 years of routing. It goes back to January 2004. We don't, unfortunately, have routing snapshots earlier, or I don't. There may be some, and it may be on your tape drives or whatever you hold really, really old stuff on, but I didn't have it. And there are some interesting parts around this. You notice that despite all the claims to the contrary, the first takeoff was slow, fractions of a percent globally. Now, the routing table started to grow around the time, wasn't January 2012 a V6 launch day or something? It was something like that. And even though the numbers were low, they were growing. But you notice in the last 10 years, all the growth. And with some variants, we're now at 200,000 routes in the IPv6 routing table. So clearly, it's all about an exponential growth. Or is it? Because this is the number of routing table entries. But there's a different picture, a subtly different picture that actually gives us a view around addresses. So let's understand this to a certain extent. If you're around that time, some of you might remember the 6-bone. Anyone remember it? This isn't real. This is a test thing. We're going to take the address away. So we occupied a different space, and the prefix was 3FFE, and we built a network in that prefix, and it's an RFC about it, that actually tried and tested in a more sort of gentle environment some V6. Most of it was overlays. We were tunneling across the V4 network. It worked for a while. It provided experience, but by January 2004, it was time to get serious. The phase out was 2004. We shut it down in 2006. And then I go to the address registries and find the early records of actually IANA allocating address blocks into the RIRs. And to say that we didn't know what we were doing, and I include IANA in all this, is probably true. The original allocations were, in today's parlance, tiny. You know, a /23 doesn't last very long. So at that point, and those were the only RIRs at the time, we each were allocated in 1999 a /23, and that's what's in the IANA registry. It may have been tiny, but it did last for 2 years. And the next allocation wasn't to the RIRs, it was actually to yet another overlay, because some of you might remember 6-4. And oddly enough, although it was really horrible, it didn't work very well, because Microsoft Windows kind of folded it in and actually went there, that and Teredo, there was an awful lot of this kind of relaying network. And so to make this work, because we had to map the entire V4 space into V6, well, that sounds like an easy task. Just give them a /16 and the map's done. So we did 2002 /16 as 6-4. So here is the map of address allocations. So those original 23s were early 2000. And then in 2007, we kind of decided that this was crazy, giving RIRs a /23, because we expected massive growth. Let's say if you were Comcast or any other big ISP, you might have started small, but you're going to have millions of customers. Do we give you lots of little allocations and eke this out the same we do in V4? That would destroy the routing table. V6 would be a mess. And so we decided instead to think about the size of the endpoint where we're going to. And it was certainly contentious, but in the regional meetings at the time, we came to a degree of consensus that each RIR would get a /12. And we thought, well, that's going to be enough for decades, won't it? A /12 is really, really, really big. And, you know, it lasted from 2007 until, 2019, when, 12 years later, both Ripe and Aaron said, I think we need another /12, thanks. And so what you actually see now is these three registries, APNIC, LACNIC, and AFRINIC, are still running on exactly the same original /12, but Ripe and Aaron have incorporated a second one. So the total amount of addresses up there has kind of shifted to, in /32's case, 7 by 10 to the 8. That's what, 700 million /32s. And here's what the RIRs did. This is the day-by-day tracking of addresses in the RIRs. And you go, well, that's a bit weird. Oh, it's LACNIC. For a little while there, LACNIC experimented with a large block allocation to Brazil, and then Brazil just did its stuff and didn't report back. And we thought, well, that's a bit of a distortion. Why don't we see the allocations within Brazil? Oh, okay. And so the correction happened in about 2013, and when Brazil was kind of normalized into the rest of the RIR system. Similar to the routing table, similar. It's kind of a growth. It's not sharply exponential, but you kind of see Ripe kind of went with it. Aaron kind of didn't until October last year. And one party was allocated a /16. Yay. LACNIC, much quieter. AFRINIC, much quieter. And even APNIC, it's kind of gentle. There are a few allocations, but it is kind of gentle in the pace of growth there. So there is growth, and it is steady, and with a few sort of blips like that /16. It's not out of control. It's not exponential, but it's steady. It's kind of there. So the overall picture, I can draw a straight line through it, and I'm not far off. So it's kind of linear across that entire pattern. Not exponential, but it kind of says, yeah, steady growth. The advertised table. How many addresses are advertised in BGP, which is not the same as the number of routing routing objects. It's the size of the address table. And here you get a different kind of picture, and it's more gentle, much more gentle. That the amount of addresses we're using in V6 has kind of a bit of an increase in 2006 as we got going. And this is every peer of RIS and route views. Not everyone sees the same network. Some folk don't take the full tables, but those that do, as we track it forward, you can kind of see it's been steady growth. But it's interestingly that at the last few, year or so, do I do any? No, I don't. The last year or so, that growth is quite gentle. It's lower than it's been ever before. So that sort of growing of the address table is actually more gentle. That's a lot of data. Let's slim it down. Single BGP feed that comes to my router. Yay, I've got the data in front of me rather than pulling it from route views and RIS. And it's a similar picture. Best fit, it grows at just under 3,000/32s per annum, which at this rate is 1/4 of the RIR allocation rate. So we're handing out 4 addresses in V6 or blocks or whatever unit you want, and we see one of them appear in the routing table and the other 3 sort of sit there in reserve, I guess. We don't see them being routed for whatever reason. So around 2.8 thousand, 2,800/32s per year is the growth rate. This is the next one. This is actually the reason why we started this massive measurement system in APNIC, because we were hearing all kinds of crud about exactly how much V6 was out there. Well, okay, let's get serious about measuring this. And we looked around for ways of measuring it. And the one thing we thought was brilliant, and I'll credit Byron Ellicott in APNIC for the stunning idea to start with. Everyone gets ads. You can't escape ads. Ads fuel the entire internet. You've all seen them. And after running these ads for nigh on 12 years, you've seen ours. I can guarantee everyone's seen ours. We push out around somewhere between 15 and 25 million ads every day. So this is a network which is, dare I say it quietly, between you and I, around about 1,000 times larger than Atlas. And the good thing about this kind of network as well is it's a new collection of 20, 25 million folk every day. And it's across the entire internet. So if you're living in the Faroe Islands, I see you eventually. Even in Antarctica, if you have the connection, I see you. I see 40,000 users on Starlink. You can see their commercial success because ads are everywhere. So anyway, I digress. What we do in this ad is really simple. Can you get to this URL? But the only way you can get there is you have V6. That's the first test. And the second test is a little bit subtler. You can get here in 4 and 6, so you'll get there. Which protocol did you use? So the first test, this is only V6, is are you capable? And that's the blue line. Are you capable? And the next one is, well, are you doing happy eyeballs? Are you really preferring V6? If you can in dual stack, will you actually use it? And for most places in the world, most of the time, users prefer to use V6 because that's what we coded. That's what we put into the algorithms. So now we're sitting at around 37% of the world's user base. This is eyeballs, not infrastructure. So a little more than 1/3 of the network is now dual stacked. I do not know, and it's very hard with the ad system to see who's doing V6 only. I suspect, between you and I, that the ad system has a V4 control plane. I suspect. Wouldn't know. Only Google can answer that. But, it's not a bad to see most of the internet at this point and around 37%. Again, big growth 2016 to 2018. COVID kind of knocked some plans on the head. And as we sort of moved into that early part of COVID, which was 2020, things are sort of slower despite that early growth. And then it's sort of gone up again. But it's all about national deployments. It's not the world. Every national picture is different. So I've done some slides because it's really easy to map this data. And if red is 0 and green is 100%, country by country, 2014 looked a lot like this, all red. I can't even see anything that's not all red. So, there was none to any intents and purposes. 2015, wow. The early adopters, and the early adopters were actually America and Norway. Hard to say if there was some work in Thailand, but, and exactly, a really early provider, Belgium. Yes, thank you, Belgium. And we know who it was too, one person. So 2016, it keeps on going. Germany starts to move as well. Move further, 2017, and it's clearer in the US and Canada. And then this next one. India is large. And if India moves, the entire dial moves with it because India is large. And so if we move again and look forward, oh, by the way, Greece, economic crisis, whatever, but let's do V6. Yay, Greece. Well done. 2018, one of the largest populations, I think it's the second largest population on the planet, isn't it? Did it. Oh, it's too hard. It'll take years. No, it's not. And it didn't. Wow. The planning behind in India must have been stunning. My hat's off to them. That is a technical feat that is just stunning. Brilliant. Brazil has moved. The US keeps on slowly churning it out. Germany is more solid. And in fact, up here in Finland is also moving. And little bits of Malaysia have also moved. But, you know, the major mover, India. And that's why the line went up, because India is big enough that the world moves when India moves, because there's a lot of people there. This is 2019, a little more definite signs of movement in India. And now you're seeing Vietnam, Thailand, as well as Malaysia joining in that. And Brazil is more solid. 2020, India's gone green. Holy crap, that's so many. That is an astonishing piece of work. China, comparable size, has gone off the bottom line. It's moving, but unlike India, 2 years straight, it's looking like taking them a lot more time. Different ways. France moved, as well as Germany is now almost complete. 2021, Saudis moved, and they moved within a year. Bang, done. Command economy and a lot of oil money. It's amazing what money will do. And you're saying Southeast Asia, and Japan's numbers are now getting higher. They were a very early adopter, but the percentage numbers were low. And don't forget, this is 0 to 100. You've got to be close to 100 to get green. 2022, we're moving across Southeast Asia, parts of Europe, but not the southern. America is basically okay. Finally, Australia goes, oh, yeah, let's do something slowly and surely. 2023, again, it's a very similar picture. That area, Europe is now, particularly France and Germany, the powerhouses in Central Europe, or at least Western Europe, are now done. And the UK, I think it was B-Sky-B, were one of the early ones, is actually moved as well. And the US is going from yellow to green slowly and surely. And the start of 2024 is where we are roughly today. So India, the story. Wow, in 2016, over a period of a few months between October and basically April, May, they rolled it out to 50% of their population in one fell swoop. 50%. Isn't that 400 million people or something? Astonishing. And since then, it's been largely fill-in and other providers. This is Bharti Airtel, who's the dominant provider in India at this point, and the rest is just now sitting at basically 80% of the population. You know, wow. If anything was going to change that market, they've changed it. And they brought all the service providers with them. If you wanted to do business in India, whether you're Google, Facebook, Apple, or anyone else, the answer from Bharti Airtel is, I need you to provide those services over 6, or it ain't going to happen. And there's a lot of us, and we're a big market. And the service providers went, okay, we'll do it. And they did. China, grand plans. But for some reason, it's just harder to do things in China, because I suspect instead of having a small number of centralized large providers, they have a number of providers, China Unicom, China Telecom, etc., but they're kind of diverse and distributed. And I think this is an organizational thing of trying to get everyone to do the same thing on the same day. You know, it's just hard. And so progress is happening, and it's inevitable, inexorable, but it's taking some years. There is no slowing down. That curve since 2021 is constantly moving. They're doing it, but they're doing it sort of more deliberately, and folk are getting the message, but it is taking some time. Malaysia, early adopter, quite early, big push, 2018 to 2020, and now at around 70%. The job is largely done. The rest is just mopping up the edges. And also in our region, Japan, really early adopter. You might remember back in the year 2000, for those of us around then, they thought they were going to be the market leader in V6. And they splashed out this stuff in their ISPs to a very small extent really early on. But it was always fractions of, small numbers of a percent. By the time 2014, they're around 5%. And it's been a slow and steady program ever since then. They're up to 50%. There's no extreme urgency about the problem. As equipment retires, I think it gets dual stacked. As your handset dies and you get a new one, it's dual stacked. It's kind of a slow replacement process rather than a concerted push. Anyone from Mongolia here? I know there's about 6 of them there. Thank you. Great work. Again, just switched it on. So, God, how can you do that? Well, we just turned it on. Brilliant. 2023, January, February, March, April, done. Kind of at that point, everyone else has to follow. Everybody else has to follow. So an astonishing achievement. They tested it for a couple of months and it's kind of, this works. Let's just do it. So they did. I'm very impressed. So where are we? Look, it's spotty. So when I said 37%, I was kind of right. But at the same time, when you go to India, France, Germany, Malaysia, Saudi Arabia, the US, Uruguay, Vietnam, and Mongolia, it's there. It's in the providers. Its stuff will work. It's just commonplace. If you go to Africa, the Middle East, Southern Europe, apart from Greece, it's not there. We don't have a common sense of urgency. We're not all motivated the same way. Others are going, oh, look, tomorrow. And what we're also seeing overall is that those growth rates are actually slowing down. There's a certain amount of market saturation going on because I don't know how many mobile phones you have, but it's probably enough. I don't know how many laptops you have, but it's probably enough. And in some ways, this is now a human population problem more than anything else, rather than I need another phone, I need another device, I need another. So the growth rates are now slowing down because the market is indeed saturating. And I think at this point, V6 is now not, I need to spend more money to make my network dual stacked. It's as the equipment ages out and gets cycled out of production, I replace it with dual stack. So we're now on a slower cycle of equipment replacement in infrastructure rather than a big bang. Mongolia, big bang. China, medium bang. India, big bang. But other places, it's kind of, yeah, we know about it, we're doing it, but we're waiting for equipment to age out before we replace them. Not perfect. Fragmentation, particularly with the DNS, is a nightmare, just an absolute nightmare. And so in general, you need to be careful with the engineering at the application level of the DNS to avoid some of the pitfalls of poor performance in the DNS. Overall, around 20% of users of V6 networks worldwide sit behind services that will not carry a fragmented V6 packet. So it works, just don't fragment your packets, because when you do that, you're making life difficult. If you're writing applications, keep everything below 1280. How does Quick work? It uses 1200 bytes per packet. Absolute ceiling. Doesn't have a fragmentation problem. That is the kind of engineering that works. I wish that I could go to the folk who say DHPv6 is better and RA is better and bang their heads together and go, look, I don't care. I'm just beyond caring. Pick one and then go away. Endless fights over which is a better way of booting up is helping nobody. And I wish the folk who are doing ULAs would just go, no. Stop confusing the rest of us. Go away. There's enough addresses you don't need private. Oh, it costs too much. Go figure this, but stop inventing complexity. It's just making our heads hurt collectively. Go away. They're not listening, are they? We do need to sort out happy eyeballs behavior. We're finding right now that when the routing for V4 and V6 is not exactly aligned, and it does need to be exactly aligned, you do the dual stack deployment. You put in V6, but everyone's still using V4 because you're sending your V6 packets to the North Pole and back. And it's kind of, when you make V6 a bit lousy in routing, no one uses it because dual stack and the way happy eyeballs work. And so we need to do some fix-ups on that. And the other thing about this is we're still battling over whether V6 and the DNS are compatible with each other. And the real answer is keep your packet small. Don't think fragmentation works in V6. It doesn't. Keep your packet small and you'll be happy. Think that it's like V4 and you won't be happy, and neither will your DNS users. And don't forget too that the whole aim of this wasn't to dual stack the world. It wasn't, well, everyone's got two protocol stacks. It was not the point. The point was that when everyone's got two protocol stacks, we can turn one off and nobody will notice. So the entire point is to actually get to a critical mass. We're never going to get to 100%. But how many percentage points do you need to get to when we can say to everyone else who hasn't got V6, it's not our problem, it's your problem? Because at some point, we're not going to spend a huge amount of effort to maintain the complexity and cost of two protocols when all it is 10 networks in, I don't know, name your favorite country that are hanging out. The answer is they will have no sway. It'll be their problem. So when we get to whatever critical mass is, then it's more than 37%. The pressure moves from you've got to deploy V6 in order to sort of future-proof into you've got to deploy V6 because a bunch of important service providers are actually going 6 only. And if you haven't got 6, you're isolated. You're not connected to anyone. So that's the last 30 years. Hopefully it's sort of been enough. I've gone as fast as I can to give some room to the other panelists. If there are any questions on that, I'd be happy to answer them right now. Otherwise, I will hand it back to Kenny. Leap to the...
Any question from the floor? Hearing none?
We're done. Thank you very
Okay,
much.
thank you, Jeff Houston. Okay, our next speaker will be Andrew from University Islam Indonesia. He's going to introduce accelerating IPv6 deployment in enterprise through strategic adoption, governance, and automation. Let's welcome Andrew.
All right, thank you very much. 3 months ago, like on December 2023, I had a chance to discuss with one of the directors in the Ministry of ICT in Indonesia during the IPv6 summit in Indonesia. And this is a question that I asked him. Do we not get bored? In the past decade, we always talk about IPv6 again and again and again, and nothing happens. So this presentation is actually part of the project of the ECF Asia, something that we are proud of. How can we actually help Indonesia to move on from IPv4 to IPv6? So unfortunately, people, especially in Indonesia, when someone going to, they don't know about the IPv6, okay, you don't know about IPv6, then let's do some workshops. And we are expecting them, once they completed the workshops, they will implement the IPv6. And it happens every single year. More workshops, more workshops, more workshops, but no one actually deploy the IPv6, even though they kind of understand how IPv6 works. Some people just simply refuse by saying, you know what, we are a content provider. We are afraid if we deploy the IPv6, something is going to, broken. And because we are living based on the ads, the publisher will get angry. Hey, why your website cannot be accessible? Oh, sorry, because we are implementing IPv6. That's not something that is, unacceptable for the publishers. So they will just drop the ads, the revenue stream will go down, and then, okay, so we probably better not to implement the IPv6. So for many times, we focus the IPv6 deployment on the technical part, where actually there is nothing wrong with the IPv6. It's faster. It's considered to be faster. It has a smaller header. Like Jeff mentioned about the happy eyeballs algorithms. It's secured by design with the IPsec. No changes in routing mechanisms. But yeah, people are still not going to use the IPv6. By the end of the day, it's actually the people that actually run the network. They are the one that decide whether I'm going to use IPv6 or not. For so many years, it's kind of like expecting something to change, but we still use the same approach. In the case of Indonesia, we had like a decades of workshops, and we are expecting, okay, so hopefully next year people will implement IPv6. And the year after, we're still hoping the same things. Hopefully next year, people will apply IPv6. So we are striving so hard in building IPv6 policy, hoping to adopt, and then nope, not today. Or why should I, right? So now we have some different kind of approach to shift the perspective looking into the IPv6, all right? Even though, again, I need to mention the internet communities are so convinced that IPv6 is good, but people just simply respond, nope, not today. We need to shift this perspective by making the IPv6 implementations, rather than the technological aspect, we move on into the mental game. So this is an example. We have to be honest, with this long number of IP address, it's easier to remember 192.168.10.1 rather than this number. And yeah, we can actually shorten the IPv6, but still, for many people, it doesn't make sense. The numbering concepts, the representations with 2401, DBE1, 0 ABC 1, what's that? It doesn't make sense. It's easier to understand 192.168.10.1. So we need to go with some concepts that can convince them that we actually need the IPv6, as long as the IPv6 is easier to understand. So here's one scenario that we put into the workshops that we have. An example is like this. A boss, asking to his engineers because he received abuse report from some other, company, and it says that we have some report on this IP address 103.555.139.77. Which IP is this thing coming from, especially in enterprises? Is it from the VLAN 1000, VLAN 2500? Is it coming from the remote network? Is it from the headquarters? Is it the VPN address? No one knows. And usually the engineer will just simply reply by, okay, let me open my Google Docs, my Google spreadsheets, my Excel file, and let me have a look which IP, which network belong to this, this IP belong to which network. So now we do something else with the IPv6. Suppose an enterprise has multiple buildings or multiple branches, whatever you name it, and then we just simply label the building number with 1,000, 2,000, 3,000, 4,000, and so on and so forth, right? So wouldn't it be easier for us if the network has the label as the number of the building, like 1,000, 1,100, 1,200, and so on and so forth. So now, this is something that we introduced to the engineers. You don't need to remember the 2404, A640, blah, 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 and so on and so forth. We just simply create a subnet called 1,000, 1,100, 2,200. So we just simply forget this part. We remove everything. You just need to remember this one. So now we do not need to remember 192.168.10. something with the prefix of 24, 23. Let's just move with the 1,000, 1,100, 2,200, and eventually you will remember this part. But the mental game that we put into the engineers is you don't have to know this number. It will be there forever. You don't have to worry. But this is something that you need to take care of. So once we have something like this, if a report came, if a boss asks an engineer about certain client who is abusing the network with the address so long, now I'll just simply look into this part. Oh, it's 2200, 0001. That means building number 2200, which is the engineering building. And that 0001 is actually VLAN for students at architecture department. So having this kind of mentality, help them to, okay, now it's actually much easier to use IPv6 rather than IPv4. I can directly address which building is this, which VLAN is this, without having to look into the Google spreadsheet, right? So this kind of approach, when we, design the network topology of the enterprises, now the engineer, they feel less burden. And we say, happy engineer, happy network. Every time we have the workshop of the IPv6, most people will just simply, okay, we understand the concept. We now deploy in a BGP router, and then that's it. Now you have IPv6 connected. But the reality is, down there, the network, they need to understand this concept first. They need to understand this concept very well. So by having something like this, we can make things more manageable, right? We can make things more manageable. So we also provide them with some scenario. How can actually we deploy IPv6? For those who are still afraid deploying IPv6, we usually recommend them to use the pilot stage. Okay, just simply implement it into your IT department, test it. We had actually a real experience back in the day, 2018, when we started implementing IPv6. We had a problem. So we split the network. One network is actually for students. The other network is actually for staff. And then when we deployed the IPv6 for the staff, the Google Drive refused to connect. And apparently our upstream, in Indonesia, usually it's very common. If you ask an ISP, why don't you implement the IPv6? And then they will reply, because my client never required me to connect them with the IPv6. So when we started the IPv6, we had a lot of problems with the upstream, right? So having this pilot stage helped them, easier the burden rather than deploying everything at once. We asked them to do it in pilot stage. And for the parallel part, like Jeff mentions, this is actually about the dual stacks. I know that in some workshops, dual stack is not preferable, but you know what? Again, I need to mention, at the end of the day, it's engineers who deploy things, right? They feel the pressures. If things don't work, right, and then everyone will get mad at them. So, okay, let's just deploy the dual stack. It's easier for them. They have the IPv4 and they have the IPv6 at the same time. And luckily, with the happy eyeballs, hopefully, the browser will adhere the request to connect with the IPv6, right? And for the last part, the cutoff, we usually never recommend this part, because if it's IPv6 native, sometimes, even though they can provide with the translations, still, it's not for the faint-hearted. It really is. It's not for the faint-hearted, right? So because there will be high risk of that our network is unreachable from the outside, especially with the situation in Indonesia where we only have like 15%, less than 15% connected via IPv6. Now we still have another problem. Okay, we have the workshops. We have the BGP being configured with IPv6, but now if we talk about enterprises usually they have tens, if not hundreds, if not thousands of equipments. And you have to be in the positions of the engineers. Okay, you teach me how to do the IPv6, and I'm happy with that one. But now you ask me to reconfigure everything at once. No way. How come I need to reconfigure 100 equipments, routers, switches, and everything else? And you expect me to do that once? You are not paying me. You're not paying me to reconfigure things. And again, my boss never asked me actually to implement the IPv6. And so they often have tens, if not hundreds, of switches, both L2, L3, thousand of access points, edge routers. So when you decide to adopt IPv6, you need to bear in mind, it's not only the edge routers, it's every single routers within the network, right? So that's why starting 2024, and thanks again for ECIF Asia providing us with the grant, now we are providing the workshop we are going to do with the automations. So now we start to use the automations using the Ansibles, because basically this is something, try to be more empathetic when you provide the workshops, because they need to address a lot of equipments, right? So using the Ansibles, we are going to push the Ansible to be the discussions on the table throughout the workshops, in a hope that, okay, you have the IPv6 right now, how can you deploy things fast? And okay, just use Ansible. And this is the thing that we are going to implement for the next workshops that we have. And lastly, this is something new. We are going to also push the thing with the generative AI. So I can imagine in the futures, a network engineer, they'll probably change their job into something else. It's still probably network engineers, but move into the strategical part rather than doing a configuration on Cisco routers, on Juniper, on MikroTik, and so forth. And let's have a look how generative AI can work. I hope the demo can run. So this is a proof of concept. Suppose we have our Cisco routers configurations over there, And then I'll just simply put an IPv6 block, and then I click convert it to the IPv6 and wait for probably like 30 seconds. Let's count it. And then, yep. We tested using Juniper, MikroTik, Ruckus, and so yeah, you have near instance configurations using IPv6 if you previously only using IPv4. Thank you.
Okay, thank you, Andrew. Any question from the floor?
Hi.
Okay, yes. Your
Lee
name and affiliation, please.
Lee Howard from IPv4.global by Hilco Streambank. This is great stuff. That tool in particular is very, very cool. I hope that you'll expand it to include not just other vendors, but firewalls, for instance, load balancers, other elements in the network. I wonder if people will adopt Ansible to deploy IPv6 before they adopt Ansible to do other deployments in their network. I think that they might have to be happy with Ansible first. Great tool though, so it's absolutely the right way to go.
Yep.
Do
Yep.
you think that you'll have to get used to Ansible?
Yeah, we basically want to because many engineers in Indonesia they don't even know what Ansible is.
Yeah.
Right. So our first task is actually to convince them that actually automations can help you a lot. Right. So once they are happy with the automations, we can actually push that one, the generative AI, because this is simply a proof of concept. We haven't tested with multiple scenarios, right? We need to understand whether they put even firewall, the policies and everything else within the configurations. But as long as it's a basic configurations, and with the help of the generative AI, we are using OpenAI right now as the API that we use. We try to use some other thing like a Gemini from the Google as well. We need to have a comparisons, but yeah, make them comfortable with the automations part first, and then everything will be easy.
Yeah, I think you've got exactly the right thing with using dual stack. You have to go to dual stack before you can go single stack. There are now ISPs, landline ISPs and mobile networks who are single stack with translation, so it can be done. But I certainly wouldn't suggest starting there. You talked in the early slides about your content providers won't deploy IPv6 because they'll lose ad revenue. And that was kind of the whole point of the World IPv6 Day, was that everybody went at the same time, so that the advertisers couldn't leave one content provider to go someplace else because they all went at once. That you might have a national V6 Day. And then the one other thing that I loved on the address planning that you're talking about, the number of your buildings, I always recommend that. You can also do it instead of building, you could do it by security policy. And then your security policy is identifiable there. And for making life easier for network engineers, I always like to ask, pick two IPv4 addresses. Are they in the same /27 in IPv4?
Correct.
You don't know.
Correct.
You can always tell instantly in IPv6.
Yep, that's the thing that we try to push. Thank you very much.
Not yet home. We still have one more question, right? From the floor.
Sorry, this one's actually for Jeff, for the previous speaker. This is from the moderator on the Zoom. And so this is from Jordi Pele Martinez. So he's saying instead of thinking in dual stack, we should aim for an IPv6 only. Then there's no need to drop IPv4 because traffic is so low that automatically disappears from most of the networks.
He's repeating what I said, right? The aim is not dual stack. The aim is V6 only. But when you get to 100% dual stack, you can drop one and you're back in V6 only easy, yes?
I believe that's what is.
You know, we did this before. I don't know, was there anyone else running DECnet? Because we were in the Australian academic community, and we were actually doing multi-protocol networking. We were doing bits of IP, bits of DECnet. Some idiot actually wanted to do national Apple talk, good on them. And, you know, after a few years, it turned out there was absolutely no traffic on DECnet or Apple talk, so we just quietly dropped it and nobody knew. Once you get the entire world going dual stack, you can drop V4 and no one will notice is the entire thing. So yeah, thank you, Jordi. That was what I was saying.
Okay, thank you. And also thank you, Andrea, for your presentation. And also especially thanks ISIP Asia to sponsor the particular program. Sophia, do you want to say something?
Thank you. Kenny. Silvia Cadena, IPNIC Foundation, just to let the community know that the call for Easy Fascia is still open until the 28th of March. And we have an IPv6 deployment category to support projects like this. At the moment, we have supported around 9 projects across the region, all linked to deployment and research in that area in different capacities. So if you have any ideas that you would like to put forward, or your organization is ready to move to the next stage, just go for it. That's what the IPv6 deployment grants are for. And all the information is in on apnic.foundation website. Thank you.
Okay, right. Thank you, Sophia. Okay, our next speaker will be Yang Gao from CERNET Corporation. She is going to introduce the progress report on supercomputing internet project and based on CERNET too. Let's welcome Yang Gao. Thank you.
Thank you. And good afternoon, everyone. I'm from CERNET. On behalf of our IPv6 team, I'm very honored to stand here to report on the progress of our supercomputing internet project based on CERNET 2 IPv6, HPC6 for short. Besides nervousness, besides feel nervous, I think it's necessary for me to introduce some background information about our project because this is the first time that I'm formally introduced this project. I don't know how many of you are familiar with our CERNET. We have 2 independent backbone network of CERNET. And the earliest one is the pure IPv6 backbone network, and which has driven the Chinese education and the research development for 30 years. Since it's established in 1994, it has come a long way to boost a network backbone span over 31 provinces around China, and with 38 core nodes and more than 4.15 T total bandwidth. And it provides services to more than 20 million users and connects more than 2,000 educational institutions. 10 years later, there came CERNET 2, the pure network, the pure IPv6 network, which is our project based on. It has 41 core nodes and more than 4.18 T total bandwidth. Those make it larger scale network backbone than CERNET. And why we use CERNET 2 to do our project? And the most important answer is the IPv6 globalization is the trend. According to IAB statement on IPv6, proposing that the new network standard should only support IPv6, no longer compatible with IPv4. That indicates IPv6 is becoming the mainstream of network development. As Chinese NRAN, CERNET take the responsibility and put into action not only our Chinese researchers, the Chinese government attach great importance on the large-scale deployment and applications on IPv6. In fact, nowadays, almost all of our new technology and the new solutions are based on CERNET 2. That's what our CERNET doing now. The second reason is CERNET itself. You know, CERNET has come a long way. It is a mature production network with many applications and resources on it. When carrying on large data transformation tasks, it may face the risk of network congestion. So compared to that, CERNET 2 has excellent data transmission performance, which guarantee a smoothness and safetyness artery network for supercomputing internet. And there are major 3 types of computing powers. And the one is basic computing power, which mainly applying on consumer internet, industry internet, and the governmental internet, etc. And there are 10 national integrated big data centers all around China. And the other two types of computing power are mainly our university members focus on. They are supercomputing power, mainly applying on scientific computing, engineering computing, and AI computing. And another one, there are totally 13 national supercomputing centers in China now. And that is our project's resource objects. And another one is intelligence computing power, which mainly used in AI computing, like machine learning, deep learning, data analytic. And that is our future connection objects. As I mentioned before, according to the official data from Chinese Ministry of Education, there are nearly 3,000 higher education institutions in China. And our CERNET and the CERNET-2 connects more than 2,000 of them. This number covers all the top class universities and regular universities. And more than 60% higher vocational and technical schools. With the popularity of AI technology and ChatGPT raised in China, more and more requirement from our universities on the supercomputing powers. And we found that universities are not only the demand side of this supercomputing power, but also the provider, with many of the universities have their own supercomputing powers in their campus. And our first practice in the supercomputing power field was began in 2020 when we participated in the project with the Chinese Science and Research Ministry, which is a Chinese government project. And the content of that project is based on our CERNET-2 network backbone, interconnect the national supercomputing centers. And besides the 100 gigabytes bandwidth connection, it provides sufficient security. And that project proved that the network aggregation computing capacity was no less than 2 e-flows and the storage no less than 1 EB. By using IVI technology, it enables the transmission between IPv4 to IPv6 and IPv6 to IPv4, and even as well as IPv6 to IPv6. In this period, 4 supercomputing centers are connected to CERNET-2 backbone with 10 to 100 gigabytes bandwidth. By participating in that project, we deeply touched the user's difficulty and needs. Those are the main difficulty for them are bandwidth and the computer power limitation. This problem not only affects the data transformation performance, but also bring user to face the risk of security. And another problem is IPv6 support issue. So we have had some progress on IPv6 deployment in China, but there is still distance from the ideal state. Like just Mr. Huskin just presented, our China is still in the not quite fast progress on the IPv6 deployment. So now IVI technology, the translation technology now is played an important role in the transmission period from V4 to V6. Due to the different applying field, there are different supercomputing powers that make there heterogeneous platforms on the market. This makes users need to spend a lot of time and energy to do the secondary compilation and the optimization of computing algorithm. And what users need is a professional service through the whole process of using supercomputing resources so that they can get timely response and solution when facing various problems. The requirement from users inspired us to draw up the blueprint of our project. We divided our project into 3 stages. The initial stage is relatively straightforward. We intend to establish a high-speed network through the dedicated private network technology to connect Chinese national computer centers and the Chinese university computer centers. That's pretty fairly easier for us because the university members are still connected to our SNET 2. And our HPC6 team takes the responsibility to develop the computing power and the service platform that cater to the fundamental demand from our university users and scientific research users, institution users. That also facilitating a centralized management for diverse supercomputing powers. In the second stage, we are going to connect more supercomputing powers. We will try to connect other cloud centers in China. And we will continue to upgrade our platform and add more functions like cloud vendor management. And besides that, we will also plan to provide the video, HPC video courses and HPC application training and even experimental platform. That's so as to expand our project to talent cultivation. And the third stage is the most long-term idea. We want to internationalize both from the supercomputing power resource, and we want to attract more international users to use our service. That's the most long-term thing we want to do. Here shows our network architecture. Sorry. Supercomputing centers connected through a dedicated or virtually dedicated high-speed network provided by SNET 2, offering access bandwidth ranging from 10 to 100 gigabytes. And the dedicated network doesn't interfere with the existing interconnection network structure with supercomputing centers. And the platform supports user access with both IPv4 and IPv6, and its control and scheduling center make users and the supercomputing centers share a unified management system. And this is the general architecture of our platform. And in the resource layer, we not only connect national supercomputing centers, university supercomputing centers, we also want to connect supercomputing centers from enterprises and even intelligence computing centers. And in the function will serve the users from 4 aspects, which are network management, computing resource scheduling, application development functions to developers, and the platform operation. And we provide security assurance and operational support. And this is the project network access status. Till now, there are 5 of the national supercomputing centers connected to our SNET 2 backbone networks. Wuxi and the Guangzhou centers has already reached the operational level, and the Changsha, Shenzhen Chinese Academic of Science supercomputing centers is under testing, and there are 2 more supercomputing centers are under negotiation. This is our test case. We built a high-speed dedicated data transmission channel of supercomputing center of Wuxi and the user of Tsinghua University. The research group of Tsinghua University connects our SNET 2 backbone network through their campus network. And this test case shows a good data transmission performance. Beijing to Wuxi single stream TCP rate can reach more than 8 gigabytes. And the solution didn't affect the campus network strategy. And it shows good data transmission security. Both the supercomputer center and the Tsinghua users, they don't need to upgrade their application systems. And still, by using the stainless translation technology IVI, it realized IPv4 to IPv6 to IPv4 and connection between Tsinghua University and Wuxi. And here is the interface of our service platform. And this platform is just began to build, and the function is still improving. And through this computing resource scheduling platform, you can see the current operational state in the supercomputing computer internet. And the platform are supposed to provide global file management and provide app store, user management, billing management, and other functions. We had a video to show the platform so far, but since the English voice is AI generated and sound a little bit funny, so I decided not to show it today. I wish I could have the opportunity to give you a better presentation next time. Here is works we are going to do, and each step we have a challenge to face. We know that we will continue to develop more supercomputing interconnections. Our goal is by the end of 2025, we want to access no less than 6 supercomputing centers. And we want all our 41 university nodes are connected. And further testing will be organized. And the platform will be continue to improve and upgrade. Especially, we will do it bilingual, both support Chinese and English, so that I can give you a better performance next time. And the third thing is very, very important too, is the trial operation of platform. We will select a subset of university users to participate in the platform trial. And we will continue monitor the data transmission and optimize the performance. Our ultimate goal is to make the project user-oriented service. And we want to transform the result of the project and form a business so that this project can be sustainable and a healthy developed. So there are a lot of long-term work we need to do, like we have to continue access the CERNET2 network, a large-scale supercomputing centers, and we will establish billing mechanism for resource service and for application stores of each supercomputing centers. And we will provide network security guarantee and maintain and continue to upgrade our platforms. And the most important thing to do is marketing and promotion. That is my job responsibility. That's very important. We want more and more users to know us and to use our platform. That is the true of our true importance in our project need to do. Well, so that's what I wanted to show you today. And finally, I want to express my deepest gratitude to the ISIF Foundation that has generously supported our project. Your support is very important to make this research happen. I'm pleased to show our progress, and I'm really eager to learn from and collaborate with all of you. And thank you very much. Thank you for taking time to listen to me. Okay.
Okay, thank you, Yang Gao. Actually, you are doing well. Don't worry. Any question? And of course, thank you, APNIC Foundation. Okay, hearing none, thank you very much. So our last speaker is Mohit Tahilian from National Institute of Technology, Katakana from India. He's going to introduce migrating NITK campus network to IPv6 he will be joined online. Is he ready? Okay, move over to you. Thank you.
Yeah. Am I audible?
Yes, can you switch to the full screen?
Yeah, I thought somebody would be sharing the slides and giving the control to me.
Okay, it's all set.
All right, thank you. So hello everyone, I'm Mohit, and I'm going to speak about migrating our campus network to IPv6. Our university is called the National Institute of Technology, Karnataka, in a place called Suratkal, which is on the southwest side of India. And I'm going to mainly focus on two aspects that this entire migration process of the internal campus network to IPv6 has been totally led with the help of undergraduate, postgraduate, and PhD students in collaboration with the faculty members at NITK. So the outline of the presentation, I'll mainly also introduce our team. We have a very nice team of students and faculty members, along with a set of IPv6 experts and advisors helping us, and speak about what has been our plan of action, what is our current network status, and how the project has been overall moving, and what are the next steps that we will have in the project. So on to the next slide. So I'm Mohit, talking to all of you, and I have another colleague of mine who is leading this project, Professor Soumya, and then we have a set of network engineers. We have members from India Internet Engineering Society. Dhruv is already attending IPNIC in person. We have students from our institute, and we have an advisory team also who is assisting us in this particular migration process. Moving to the next slide. We actually chalked out a few plan of actions when we started off this project. We wanted to start the project by actually setting up a small test bed at NITK before we go on to migrate our production network into IPv6. We already know from the previous presentation today that India has already been moving towards IPv6. We have a lot of support from the internet service providers in terms of IPv6 connections, but what we lack is the universities and the enterprises have still not migrated. So this was one of our major motivation to take up the project. We have, as I will discuss in one of my upcoming slides, we have a pretty huge network connecting 45,000 plus terminals. And we said before we go and migrate the internal network to IPv6, it would be good for us to set up a small test bed so that we can gain some insights from this test bed by working on the existing solutions for DDI, the DHCP v6, the DNS, and IPAM. We then subsequently decided that we will migrate our network services at the production level. We'll migrate our DHCP servers or DNS servers and IPAM to IPv6. And we obviously wanted to go ahead first with the dual stack deployment, like everybody has been already mentioning, and then subsequently start migrating our web services and applications at NITK to start supporting IPv6. We have some custom applications in our university. For example, one of them is called Integrated Resource and Information Sharing, abbreviated as IRIS, which is kind of a management information system developed in-house by our university. And almost every student, faculty member, and staff members of the university, we use this particular application on an everyday basis. We also have a lot of users connecting from outside the network, particularly those students who go for internships and who go to work with some industries, but they also want to conduct some research along with their professors back in the university. So they need VPN accesses. So we also wanted to see that we can enable IPv6 for all the VPN connections. And one of the most important and tangible outcome that we anticipate from this particular project going forward is to be able to document the entire process of migrating in detail and capture the process at every step of migration, and then see that if that documentation can be then provided to other universities, and maybe they can give us the feedback whether the documentation is good and if any corrections are needed, and then they are able to migrate their campus networks to IPv6 using these documentations. On to the next slide. So the current network at NITK comprises of 45,000 terminals, and we also have yet another campus coming up within a radius of 40 kilometers. So we will have many more terminals connecting to internet from the campus. We have more than 350 switches, 1,200 indoor-outdoor Wi-Fi access points. We also have a dedicated data center that hosts our firewalls, our core switches, our web and application servers, and everything that a data center usually should have. On the next slide, we will talk about what did we do with terms of IPv6 block. So first of all, we had multiple options. We had an option actually to lease an IPv6 address block. We can request our ISP. Our ISP is named as Bharat Sanchar Nigam Limited. It's Government of India's entity, BSNL in short, and they support IPv6. So one option that we had is to go ahead and request them, and they would provide us a chunk of addresses from their block. But there are certain policies that they can only allocate a certain IPv6 address block of certain sizes, whereas we wanted to have a /32 IPv6 address, thinking of the fact that we have one campus, we have another campus coming up. We also have planned for going for the disaster recovery sites. We also have certain cloud applications. So we thought it would be much better. We have our own address block of /32, and we went ahead and we requested from our local internet registry, which is called IRIN, Nixie. We also got support from BSNL on the previous slide itself, that BSNL helped us in terms of advertising our IPv6 block. So we haven't been running our own BGP instances or our own ASN. We are using the ASN of BSNL, as you can see in this slide, which we have taken snapshots from the Hurricane Electric Internet Services. Our IPv6 address block is being advertised, and we did not choose to advertise all /32 in the beginning. We said /36 would be sufficient, and then we went ahead and did that. So thanks to our ISP for helping us in this regard. On the next slide is a small glimpse of how we set up a testbed at NITK. We picked up 5 machines in a lab, and we started configuring them. One of them to be a DHCP-v6 server, one of them to be a DNS server, one of them was set up to be an OpenSense firewall. And another important thing that we had to do is we did not want to disturb our entire campus network. So we wanted this testbed to be kind of within the network, but being an isolated part of it. So initially we went ahead and we set up a kind of a tunnel of v6 over v4 that eventually then we have moved forward, and now this testbed has been working perfectly fine. And we also have some statistics to show you as we move forward on this particular slide. Yeah, so on the next slide, on the testbed, we started performing experiments. Once we had the testbed running, once we had the IPv6 block being advertised by our ISP, we started performing experiments. First things were the common ones, where we set up DDI, we set up the DNS servers, we set up the DHCP servers, the IPAM. And then we also noticed certain issues, for example, with respect to the ND snooping that was happening on the intermediate switch. So typically it is used to protect the ND attacks by constructing a table of the IPv6 MAC binding. But what was the issue that we observed is that the table entries were generated only when machines were getting rebooted. We kind of did a little bit of analysis, although the entire debugging is in process. But our analysis was that probably the entries are maybe getting generated only when the system first joins the network and starts advertising the IP. But we are still in debugging process, and we are taking a look at how we can resolve this particular issue. On the next slide, as we will discuss about the other things, for instance, we also had an IPv6 deployment workshop at NITK last year in the university. We had 92 participants overall in this workshop, which was held in the month of March. We also have an upcoming workshop in this year in March. Dates are from March 9th to March 13th. And we had participants coming from industries, government organizations, and several students and faculty members also attended this particular workshop. Moving forward on the slide, we actually started then thinking of migrating the applications to IPv6. So I have a separate team of students. One team of students is working on infrastructure migration, whereas another team of students is working on migrating the applications. As I mentioned, integrated resource and information sharing has been one of the most widely used utility at NITK, and we have more than 7,000 students, 600 staff members using it on everyday basis. I'm glad to report that with the help of this particular project, we have been able to successfully migrate IRIS to support IPv6 for the external users. That means anybody coming on iris.nitk.ac.in from outside NITK having an IPv6 address will be getting served on IPv6. And these are some of the numbers that I have put up on the slide that what has been achieved so far. So we have already enabled IPv6 for the external users. The next job is to start enabling IPv6 for the users within. We don't have IPv6 within the campus as of now. And these are the set of things. I have another statistics, so I will mainly talk about them there, but I want to highlight one point which is mentioned at the last part of the slide, is that we haven't yet done any kind of performance evaluation or testing in terms of how has been the latency and what has been the response time once we have started supporting IPv6. We are still in the process of doing that. However, there are some interesting statistics as we go forward. So on the next slide, related to IRIS, there are several third-party utilities that we have been using inside the campus. Some of them are listed here. For example, we have an Nginx proxy or load balancer, which we have also migrated to IPv6. We have Ruby on Rails application, which again has been migrated successfully when this particular process was completed. And I'm happy to also report that we have been able to also migrate our VPN services that we use at NITK to be supported on IPv6. And these have been tested by some of the students who are working from outside NITK, and they use the IPv6 enabled VPNs to see whether they are able to connect to the systems and connect to the network successfully. On the next slide is we have the discussion on one of the major issues that we faced when we were trying to migrate our applications to IPv6. All the applications that we were running through Docker networks, we faced several issues. The most important issue was that we found that the containerized services were inaccessible via the IPv6 because of the NAT setup that is internally used in the Docker networks. And one of the ways that we tried figuring it out, although it is still a kind of a temporary solution, we are still looking into how to go and fix this, is we configured the Docker kind of right now to use a local IPv6 address, and also established an external connectivity via NAT by forwarding specific ports to reverse proxies. On the next slide is the last slide about migration of applications to IPv6, where we have an internally hosted GitLab for maintaining our code bases related to the applications and also research projects. This also has been successfully migrated to IPv6. What's pending is that we have a major Kubernetes deployment inside the campus, which runs our Moodle learning management system, which is something we have to still migrate because we are using an older version of Kubernetes, which doesn't support IPv6 yet. So we have to migrate, first of all, to a newer version of Kubernetes and then try enabling IPv6 and see what kind of issues we face. But still, it's a work under progress and a lot of things are still pending in this regard. Moving on to the next slide, we have some statistics that we have obtained over the last 6 months of IRIS, and then we have distributed them with respect to what are the different ISPs. So no surprises here. We have a majority of the IPv6 coming from Reliance Jio, followed by Airtel, and then other ISPs. And then on the next slide, we have statistics about what are the different operating systems from where we are getting the traffic on IRIS. And we also noted that there's a lot of IPv4 traffic coming on our systems, particularly which are Windows-based, and most likely these are the desktop machines that are being used inside the campus. And then we have nice statistics obtained. For example, we see all the machines, majority of the machines from Linux, Android, and iOS. Most of the hits of IPv6 are from these operating systems at this point of time. Going to the next slide, we also have this statistics when it was just 40 days of statistics collection. This is sometime during the month of November. We had 2 of our girl students travel to ITF, at Prague, which happened in November. And you can see 2 of our students, one was Kavya, who was presenting the statistics over there. And then there is another student who is presenting the testbed setup that we did. And we got a very positive feedback. And we also got some really nice insights from V6 Ops working group, who give us insights as to how we can proceed forward, taking forward this work and also documenting it so that it can be also brought to forums such as ITF. On the next slide, we have also migrated our entire data center VLAN to IPv6. So our data center contains critical infrastructures like firewalls and storage systems. All of them have been successfully migrated to V6. And now we are going to start migrating other VLANs into the campus network. And we have, by the way, documented all of this. We have documented how IPv6 testbed was set up. we have documented how Iris was migrated to IPv6 for the external users and how we have migrated the data center VLAN. So we have prepared 3 separate set of documents with step-by-step process as to how we can migrate all of these services to IPv6. On the next slide is a simple diagram that is just representing the migration of our data center to VLAN. There's a detailed doc which I will also be sharing with the APNIC team. We have already submitted some of these documents to our funding partners, and then we are just waiting for the feedback from them, and these all will be soon made publicly available. These diagrams and the explanations of every step what we have taken to migrate. This is the actual infrastructure that we have in the DC at NITK. Yeah, going forward, we have also enabled VPN. I already mentioned that we have been already using VPN. Our students have been testing it frequently. We haven't seen any major issues, but as I mentioned, there's still some work pending. We have not done any measurements as of now. We have not noticed packet losses. We have not been tracking latency or other parameters. That's in the next task, which I will talk in the last couple of slides. On the next slide, please. The next step that we envision over the next 2 to 3 months is that we want to wrap up our experiments on testbed by also checking some of the firewall rules on the OpenSense router, and also start doing the profiling for the services that are running on V6 and V4. And as I mentioned, we have still not migrated our Kubernetes deployment of Moodle. We also have Big Blue buttons for video conferencing, Jitsi for video conferencing, which we are not migrated. And some of the documentations now, which are mentioned in process here, we just completed a couple of days back. And then we have the first 3 documentations already completed. Yeah, on the next slide, please. So thank you so much for giving us an opportunity to make the presentation here. I would also take an opportunity to thank ICF Asia for generously funding this project. It has been a great learning experience for all the faculty members and the students at NITK, and we look forward to working together with all of you. Thank you again.
Okay, thank you, Moha. And any other question from the floor or online? Okay, hearing none. Thanks again. Also, thanks ICF Asia to generate support for IPv6 deployment. And if you have any requirement like IPv6 deployment, feel free to submit your grant proposal to ICF Asia. Thank you very much. And thank you, Moha, again.
Thank you.
We already covered all the presentation slides on our agenda. So before I conclude the section, and can we give a big hand to all speakers today? Okay, thank you very much. Thank you for your participation. This section officially concludes. Thank you very much.